Oh, hello. Welcome back to the continuing lecture in return on investment and macroeconomics, or the macroeconomy. Macroeconomy. Um, well, it's the macroeconomics as well as macroeconomy because I would, the direction of this lecture is more um into uh, the connection between return on investment and the macroeconomy rather than the macroeconomic theories. But of course, it will have to deal with some macroeconomic theories. Uh, if I quickly um, sum up what we discussed in our last video, is that uh, there can be several categorizations, right, of the interest rates. And why interest rate? Remember, interest rate is the the rock bottom baseline of all return on investments, right? Because interest rate is risk free or riskless return on the money. You don't consider, now if you think about it, you may not consider interest rate as return on investment because you never think you're actively investing. Of course, when you put your money in the bank, you're just doing some money management, not more than, no more than just money management. So you're passive, but then the bank is using that money, right? So vicariously, you are investing. The bank is actively managing that money, so they are actively investing or lending that money, and vicariously, you will be investing, but passively. So interest rate is is the return on your money, and vicariously the return on your passive investment. Makes sense? And it is the risk-free investment because as far as all the investments are concerned, uh, they come with the risk, right? Some degree of risk, some with more, some less, right? But it is inevitable that it's inevitable. Risk is inevitable. But when you put your money in uh, a CD account, right? The bank is using that money and they bear that risk. They can lose that money, but they still give you guaranteed 1% or whatever is the stated interest rate on that CD. So, in that sense, we have, you probably haven't thought very much about the interest rate so far, but it plays a very key role in the macroeconomy. Interest rate plays a very key role in the macroeconomy as the price, the minimum price. Price for what? Now let's think about it. You probably have never thought about interest rate this way, but interest rate is a kind of price, isn't that right? Mm-hmm. Yes, it's the price for what? Price for borrowing money, isn't that right? Interest rate is uh, the bottom line for borrowing money. And by bottom line, I'm the baseline, right? Uh, it means that all the other return on investment would have to be greater than interest rate. Make sense? Why? Because all investments involve risk, and the interest rate is a kind return on investment is like the premium or the reward for taking the risk. And the interest rate is the risk-free return, meaning, it is the reward for taking no risk, right? But then think about it. Any investment opportunity that has higher risk than the bank savings account or CD, and then that investment opportunity must pay higher return than bank interest rate to be attractive to the investors. Make sense? If no investment pays with higher risk than bank, the CD, if they don't pay higher return than the interest rate on CD, then who would invest? They will simply put their money in the bank. Make sense? So that also ties in together with the concept of default risk, right? Remember, every borrower has the risk rating, right? Called default risk, right? And the risk rating or credit rating or credit score is basically a rating of risk, right? So the higher the credit score, you're safer, you're safer borrower, right? And the lender will be more willing to lend to a safer borrower. Make sense? And lending is a kind of investing, right? It's lending is a very basic form of investing. So as the credit score goes up, safer borrower, lower risk. As the credit rating goes down, riskier borrower, therefore lenders are less willing to lend, unwilling to lend. So think about it. If you are a high quality borrower with very high credit rating, your borrowing rate, the interest rate, would have to go down because your default risk is low. You're a safe borrower. Your risk is lower. You don't have to pay a high premium to borrow. The lenders are more willing to lend to you rather than to high-risk borrowers. And the high-risk borrowers, they will have to offer higher return. In other words, pay a higher interest rate to stay competitive in the market, in the financial market, right? To attract borrowers, okay? So, so the concept also, this risk concept explains why interest rate is the baseline of all return on investment, and why default risk plays a critical role in determining the borrowing rate, right? And again, that's why it brings us back to the first statement that I made at the beginning of this video segment. I said interest rate plays a very crucial role in the economy as the price for borrowing money. Makes sense? Because it's the lowest bottom line, riskless return on the money. Now think about it. Then if that is the case, when interest rate goes up, all the return on investments would go up too. They will have to match the now think about it. When bank interest rate, which is risk-free return on the money, risk-free return on the investment goes up, then all the other borrowers, individuals or institutions or businesses, right? They will all also have to match that increase to still stay competitive and attractive in the financial market. Make sense? And when this interest rate goes down, then all the return on investments will have to also follow. And they can, now pay lower interest rate because the the major, the major industry trendsetter is lowering what they pay, right, on the borrowing, right? So that, if you understand the concept, now we'll move on to the nominal interest rate versus real interest rate. We also discussed this in the last video, but let me use one more thing here. So actually, what you see here, this is an approximation. Nominal interest rate equals real interest rate plus inflation. This is an approximation. Why? First of all, think about it. The example we used last time was, 10% interest rate, nominal interest rate, and 10% inflation, right? So it was like, our example was like, you put $10,000 in the bank, and interest rate is 10%. The nominal interest rate is 10%. And there has been 10% inflation, right? So then 1 year later, in terms of purchasing power, actual purchasing power of the money, nominally there will be $11,000 in your bank account, but with 10% inflation, actual purchasing power of that 11,000 is still the same as 1 year ago. You can still buy because everything is 10% more expensive. Even with $11,000, you can still buy only 10,000 bottles of water because each bottle is now $1.10. So it was easy to understand, very intuitive, right? 10% nominal interest rate is wiped out by 10% inflation. And this wasn't that difficult because they were both 10%. But what if the nominal interest rate was 10% and inflation was 5%? Oh, you might say, oh, then the real interest rate is 5%. Yes, I mean, but I said it's an approximation. But in terms of dollars, let's think about it. You have $11,000 now, and inflation was 5%. What does that mean? The bottle of water is now $1.05, 1.05, right? So then with $11,000, how many bottles can you, you will need to simply divide 11,000 by, $1.05, right? And you can, calculate the number of bottles you can buy. But here's the thing. People may think easily, they can add, when there is, 5% inflation, some people, this is very common mistake because people haven't been doing math for a long time. They think they can subtract percentage from dollars, right? From $11,000, they can 5%. Now, of course, that everybody can tell that's wrong because, from $11,000 to subtract 5%, you will have to calculate 5% of, $10,000. Not, you cannot directly subtract percentage from dollars. Um, but the reason I'm saying this is only an approximation is because of the Fisher, what is called Fisher rule. Actually, this um, formula is um, an approximation that was um, developed, or I mean, if you think about it, it's an easy thing. But back in 1950s, 40s, 40s and 50s, this was it was even earlier than that. I think it was, early 20th century. Um, British economist, I forgot his first name, but Fisher, Irving Fisher, I think it was name, was Irving Fisher. Um, uh, he cracked the connection between the inflation and economic growth and so on, interest rate, and then because he developed this formula, it's called Fisher equation. But the original Fisher equation is not this simple. This is an approximation. Let me switch to a whiteboard, and let's see. All right, I guess I can quickly go to a blank whiteboard. And do you all see the whiteboard? I hope you can. I hope you see this whiteboard. All righty. So the Fisher equation is basically something like this. Actually, you understand that let me make sure this is what you really see. Okay, I think this is what you see. Okay. So, oh, what's going on? So Fisher equation is, oh, why is this happening? Sorry, I'm trying to, this is showing you all the, okay, so whiteboard, right? You see the whiteboard? Now, so the idea is like this. If, as I said, this is a approximation. If nominal interest rate is real interest rate plus inflation. Now, please bear with my handwriting because this is not really writing. It's actually drawing this with the mouse, so it's not really writing. So if that is the case, real interest rate is nominal interest rate minus inflation. But how did this come about? You might think it is quite intuitive, but actually it is more like this. Now, if you put $1 in a bank, and let's say nominal interest rate is uppercase R, okay, nominal interest rate is uppercase R, or that's the same thing as, let me use, oh God, if I use, and consider that uppercase R is the same thing as I, okay? I put uppercase R, but that's I. So I cannot. Okay. See, the one thing with the whiteboard is it clears everything. If I click on, so let me do this again. Nominal interest rate is real interest rate plus inflation, which is actually, so you can find real interest rate by nominal interest rate minus inflation. But actually the original form was like, if you think about it, you don't have to write 1 because 1, it is, it doesn't change anything. But if you put $1 in the bank, and if it earns nominal interest rate of 10%, and then that is actually the result of $1, right? Earning 1 plus real interest rate times 1 plus inflation, right? Makes sense? And then you can ignore that $1, right? Now then, think about it. This is the original Fisher equation, okay? Because nominal interest rate will have to be discounted. Nominal interest rate is the result of, inflation is eating up, right? If inflation is eating up the nominal interest rate, so that, in other words, that means if the inflation is 5%, right, this will be smaller by 5%. So in other words, I will not use, okay. Real interest rate is actually then, real interest rate is what? In other words, 1 plus, forget it, this one. So, so what I'm saying is, if you will need to adjust, right, nominal, the output of the nominal interest rate, right? 1 plus $1 times 1 plus 10%. You will need to discount it by 1 plus inflation, right? In other words, if your money becomes, you put $10,000 today in a bank, and with the nominal interest rate of 10%, it will grow to $11,000, right? But if there was 5% inflation between, a year ago and now, then you will need to adjust it by the growth in the price level. You will need to adjust this $11,000 by the growth in the price level. So think about it. Everything is 5% more expensive. So a bottle of water that was $1 a year ago is now $1.05, which is achieved by $1 times 1.05, the inflation rate, right? So then you are making an adjustment to your $1.10 by the increase in price level, which is $1.05. And then you get 1 plus real interest rate, right? After adjusting, in other words, intuitively, you will think that if the nominal rate is 10%, $1 will be $1.10 a year later. And if the price level is higher by 5%, then every the real nominal interest rate will be um, eroded, right? That $1.10 will lose value by as much as uh, 5 cents, right? So you will easily think, the real interest rate is then 5%. Uh, yes, that's the idea behind this. But that, as I said, that is an approximation. The exact relationship is like this. Then think about it. Because think about it. When you get to this is like 12 equals 3 times 4, right? So if you want to know what is 3, then you will have to divide 12 by 4. Make sense? Um, Basically, all equations are based on the relationship, this relationship, z equals x times y. So if you can identify what is x, what is y, what is z, then solving for x is simple, right? X is z divided by y is z divided by x, and z is x times y. Isn't that right? So 1 plus r is simply the nominal interest rate over 1 plus nominal interest rate over 1 plus inflation. Okay? Now, if you isolate r only, what do you get? Of course, then it's 1 plus nominal interest rate over 1 plus pi. And pi is not 3.14, right? It's just, 3.14. No, arguably, uh, is pi, but pi is a symbol. You can use the symbol to adapt to your particular context. And in macroeconomics context, pi stands for inflation. And in microeconomics context, it stands for profit. But anyway, then the exact relationship is like this. Um, Real interest rate is 1 plus nominal rate over 1 plus pi minus 1. Makes sense? Now, this is what's called Fisher equation. But then, question is, what is the implication of this Fisher equation? The implication is inflation always reduces the real interest rate. Okay, so you might think, mathematically that's what it's saying. What's the big deal about it? The big deal is if you put yourself in the lender's shoes, right? This is a bad news. Inflation is always bad news. Why? Because when you lend $10,000 at 10%, 1 year later, you get $11,000 back. But if there has been 10% inflation, then although you have nominally $11,000, in terms of purchasing power, $11,000 can only buy as much as what $10,000 could buy a year ago. So it's like you lended money for free, right? But then think about it. This is a bad news for the lender, but isn't this a wonderful news for the borrower, right? If you borrowed money and you pay back $11,000, yes, but actually money is worth 10% less, so it's like just paying back $10,000, right? And don't you think this would encourage borrowing, right? When there's an inflation, right? It's a factor that contributes to increased borrowing. And you might think, oh, what's so good about increased borrowing? I mean, isn't borrowing a bad? No, it's not necessarily a bad thing. It's a very crucial, it plays a crucial role in the economy. And we'll talk further, we'll talk more about this in the next video. Okay, uh, thank you for watching, and